All right, hello, welcome to MD Helicopters Maintenance Updates in Review. This is from the OEM, Original Equipment Manufacturer, covering service bulletins and inspections. My name's Jason Green. I'm the Maintenance Training Manager. There's my email if you guys need to contact or office phone. On this particular slide up to the right, you'll see the maintenance training. The courses we offer that will go into more in depth on this technical information from the manufacturer. The most common one is the MD 500 D&E 2-week course. We also offer the F, the 520 NOTAR 2-week course, the 600 and the 900. And that's the number if you want to schedule with the training coordinator. So, but today we're going to go into a briefing covering the recent service bulletins. There's also a web link down on the bottom right, mdhelicopters.com /training/maintenance. And that will link you directly to our website, and you can find additional information in there. All right, first slide is just going to cover like a brief overview of what we're going to cover in this specific briefing. So again, manufacturer review of service bulletins and maintenance procedures. So the first one is the specific service bulletin covering the tail rotor pedals support bracket inspection, which this will be dated 28 June 2023. There has been a revision to this. So we did our initial release and then quickly revised that bulletin as well. You can see the applicability I put on there for you to look at as your service bulletin, or SB for your D and E model. The numbers, that's your serial number 231 for the D, E model 131, and F model 122. And they're all R1. The old format was a .1, but now we're using R1. Also, we're going to go through the IPC 4, which is going to cover the part numbers and applicability on that as well. Second part of this brief will be the HMI 2 and the temporary revisions that were issued out as soon as we can release them, covering this information, integrating the service bulletin into the maintenance manual to pick up not only the inspections, but the instructions and the applicable 100 and 300 hour inspections. So this will be on temporary revision 23-001 and release in June 2023, of course. The applicable pages we're going to be covering in the brief, and temporary revision 23-002, which was released about a month later. And it changed some of those. So again, we had the initial issue and a quick revision on that. The last part, if we have time for it, which I think we will, we'll be covering chapter 5 items on the inspections and some additional maintenance finding picks that we have for you, just things to look for on the aircraft around the pedal area. This would be the support bracket, the interconnect tube, and the ABC bolts, or adjustable bushing company bolts, and the gap checks we do to ensure this whole system is operating properly. So that'll be reference 67 flight controls -20-10 section. All right, the first one on the service bulletins, pedal support bracket. I kind of want to tell you where to go to. So you go to mdhelicopters.com and you can see the support bracket will be covered under support, tech pubs, notices. And if you click that link or go to that one, it will actually send you to a downloadable tech pubs notice section, a PDF, or you can go to my MD Arrow on the maintenance manuals. So you can get to this in different ways. If you have an account set up with us with the technical manuals, you would go through my MD Arrow. You could also link directly to the tech pubs himself. All right, so the first one is the link to my MD Arrow. And this is with no login required. And you can actually go to that link. And then if you carefully look on there, you'll see tech pubs, and that's the no login. And then there'll be a kind of a back door to these pubs you see listed here on the index. And I've highlighted the one in orange you can see boxed out. This is a service bulletin list. It's like a package, and you can download all the bulletins on our aircraft and the model applicabilities all in one. You're going to have to sort for it and find what you're looking for within that master list in that document. But that gives the ability to customers so they can download and look at the information on all the service bulletins. And you can see technical bulletins here, service letters, so all three of them. And the indexes too are important when setting up to make sure you have all your documentation for that particular model to cover. So your indexes is your master list of all applicable bulletins. So if you click that one, it's going to come down to the right here. I've highlighted another one. It'll tell you like this example is a D model, and this would be 231 revision 1, like we went through earlier. This covers a specific 369 Alpha 7505-7-8, and then -14 and -15 version of this. Very specific on the dash numbers. Remember, if the bulletin doesn't list a dash number, then it's all of them, but these are listed in dash numbers, so it's specifically those. The tail rotor pedals support bracket inspection, and the most recent one. So you can also, we recommend to the mechanics coming in here and checking to make sure their bulletins are up to date, that they're following the latest revision. If it's like, you can see an example up here. Above is R2. This is a second revision on the tail rotor torque interconnect tube. So at least once a month, you guys should be checking this stuff because they get updated just like your maintenance manuals. And technically, these are released as standalone inspection documents until we integrate them into the maintenance manual and, of course, the initial sign-offs. So that's one way. It's free, no login, and you can access what you need to do the inspections. All right, this is the other way you can get into the technical publications, probably most common for everybody if they already have an account set up with us for maintenance. And this is the MD Helicopters only technical publication access portal that'll go through My MD Aero. And if you click through there, eventually you'll have a couple of portals you'll go through, which is going to dump you out at the old ATP, which is now, where you guys probably know, Very On Publications. And there's a couple links up here if you guys need them to get into the publications as well. This will be on a subscription-based thing, so you should have an account set up. And this will access libraries of not just our aircraft, but whatever you have registered. But you can see here, I'd already pulled up this bulletin, so they have quick access to view these bulletins as well. So just another way to get there. Also, the maintenance manuals will be in here, not just the bulletins. All the manuals will be in here. Okay, and this is the beginning of the first one. So that's how you navigate to it. And then you can download them in PDFs. I've broken this up so you can see it on the screen. This is the one service bulletin we're going to go through. And these are the manufacturer mandatory bulletins. And this little asterisk at the top, always read these first. So they'll tell you that this bulletin was originally issued out on the serial number range and the date that was originally issued out, and then revised to add the dye penetrant inspection to this bulletin. So we'll try to get these out as soon as possible, as soon as we have a problem with an aircraft, and then we revise them as we get good data from the field through field service and into our engineering. Also within the class, we get this information into engineering, and that's the reason for the updates. The dye penetrant inspection was added to be more useful or friendly for the mechanics in the field to perform this inspection. So this covers a tail rotor pedal support bracket inspection, the part numbers, the dash numbers, the planning information, affected models. So this is the first thing that's going to capture you on applicability, which will be all 369H, the D models, E's, F's or FF, all F models, 500 NOTAR, and 600. This is pretty much our complete single engine family of modeled aircraft. The pedal assembly you can see on the right is shared among all those aircraft. Assembly components affected by this notice. This is your part number ranges here. So if you have those, which 90% of these you're going to have, well, probably 99% you're going to have these, except for the newer aircraft models. You'll have the aluminum version of these, which we'll get into. So Charlie here, the reason there have been reports that the use of the pedals as leverage can cause cracks in the magnesium tail rotor pedal support bracket assembly. So I've highlighted these bracket areas, and the magnesium, which was the most common we used and built for many years, like 30, 40 years. They generally spoke here of leverage. What this entails is the pilots or crew members, if they're not flying, obviously, if you guys get inside the cockpit and they're putting their feet up on both pedals and they're pushing back into the seat, and that's causing a lot of stress in these bracket assemblies over time. The actual flight loads on this is not near enough to cause any problems, but the misuse of pushing on these and using your legs as power is causing stress on the magnesium. So that's why this bulletin's coming out. Failure to comply with this bulletin can cause a loss of anti-torque authority and directional control. So obviously, if we have cracks on the tail rotor assembly on any helicopter, that would be a problem. So description. So procedures in this bulletin will give owners and operators information to do a reoccurring inspection of magnesium tail rotor pedal support bracket assemblies for cracks in corrosion. So that's kind of the backwards, but in a way, if you get corrosion inside this area, this will be on the nose of your helicopter. And this could be in saltwater environments or boat operators or around the Gulf or coastal operators. You want to definitely look in these areas for corrosion and white magnesium type corrosion. This is going to cause the weakening of the magnesium and cracks forming prematurely. So corrosion's a big one to prevent and to look at those areas. Keep them clean, wiping them, freshwater rinsing areas the best you can in this area too, if in those environments. All right, the next section, next page we have, continuing on the service bulletin, will be echo time of compliance. There's going to be two things I tried to summarize on the right, if you can see that, but I'll just read through those. The visual inspection in this bulletin must be completed within the next 25 flight hours and every 100 hour, and annual inspection thereafter. Okay, so that's the first part of it. And again, summarized over here. So your visual inspection will be within the initial 25 hours receipt of this bulletin. So that's pretty early. Most people have been doing this or have done this already to show compliance with that. And then the next one for compliance that they mentioned on the top one is every 100 hours after that. So this will be kind of a new visual inspection. Well, not totally new. It's a clarification to make sure you're doing this inspection as well, because the pedals have always been an inspection point, but this is really detailing out specifically what we want you to see. So initial 25 and then every 100 hour. Unless you're sitting the aircraft around, then you may hit the annual. So this is going to get your high time flyers first on the 100 hour as an interval every 100. If the aircraft doesn't fly a lot, at least on the annual. So these are different checkpoints based on your operations. The second part of this time of compliance is the non-destructive inspection, or NDI, in this bulletin must be completed within the next 50-hour flight hours and every 300 hours thereafter for magnesium tail rotor pedal support bracket assemblies. So this is your NDI summarized on the right. This particular one has a 50-hour, a little bit bigger window you can plan for. And then every 300 hours. So this will be on your big, say, phase or your big downtime. So you'll be doing your 100-hour, 100-hour, and then on a third one, you're going to be picking up the NDI inspection. All right, so those are the intervals, the initials within, and then the routine or every after that. These are FAA approval, technical designs, aspects of the bulletin are FAA approved, so this has gone through them. Labor hours, compliance with this bulletin will be approximately a half hour, man hour for visual inspections, and 2 man hours for the non-destructive inspection, so NDI. All right, now going into the actual instructions, we'll reference a figure. I've done a additional colorization, highlighting, and additional part numbers. It's not on the bulletin, it's on the right, just to help in the instruction video here. But note the part number and note that it's magnesium. So your magnesium brackets are called out, obviously. If you guys have the newer aircraft or the 369 November N here, that N, anytime you see the 369N, that means that part is now made out of an alternate material and it is aluminum. Okay, so this is aluminum bracket assemblies that will be non-applicable to this bulletin. So that is your preferred part, -1 and -2. And I've tried to highlight here in 2 groups so you can pay attention to the right hand pedal assembly, right hand tail rotor pedal support bracket, and it's grouping its part numbers 369N. And then on the left-hand side, it's a -2. So again, that's the first thing you want to do is see if you have to do this inspection or not. So alpha tail rotor pedal support bracket visual inspection. Okay, identify installed left and right hand magnesium, and they're kind of reiterating that. So number 2, examine the tail rotor pedal support bracket for cracks and corrosion with a 10 by magnifying glass and a mirror and a bright light. So these will be done accessing the pilot or co-pilot's doors, position yourself up inside the aircraft and looking down through the top of the chin bubble back with a mirror and focusing on these areas, okay? And having sufficient bright light is always going to be critical in this area. It is permitted to use a borescope to examine the tail rotor pedals support bracket. And we've been using a lot of the newer borescopes with your cell phones or smart device or laptops or tablets, and the digital cameras get down in these areas and give you real good visual indications of how your brackets are doing and your pedals and your torque tubes. So inside areas you can't see. So the borescope's a real good way to inspect for these areas too, especially on the initial inspections and focusing in on these areas. Once you get in the interval, you know how your aircraft is, you're looking for things, it's a lot better, but the initial really needs to be examined carefully. All right, and the next slide we have here is a breakdown from the IPC4 and applicability. This is additional historical knowledge on the IPC. So you need to go through and find out, plot what dash number you have. These are initial issues out of the factory serial number ranges, and you could have changed them out. You could have upgraded by then, but you could see here, I started on the top left here, comes in on the left, -7 bracket assembly comes down, identifies its magnesium. It's telling you here the -14, okay, is replaced it. So now most current one out there was the -14, the latest and greatest, and that would have been the older one. The -14 assembly, right hand side, magnesium, and then it'll tell you that was replaced, okay, by the aluminum one, which will come back down here, and the serial number ranges. So if you follow with the serial numbers here and you fall into these ranges, these are a newer aircraft that are being produced and manufactured with the aluminum brackets. So this inspection would not be applicable for those. This would all be your right hand in the orange area. And then we have the gray boxed area next. And that's going to be set up for the left-hand side. So you can follow those part numbers. It was 8 to 15 down to the aluminum -2. The only error I see here, it looks like we're gonna have to update too, is this is calling out right hand. This is actually your left hand. So this is all left hand here. So the right hand one is up here in the -1. So, okay, so over on the right too, we just put some part numbers in here to give you the full part number and assembly. All right, the next service bulletin page, it'll tell you carefully examine the lug area for cracks and corrosion, carefully examine the web area for cracks and corrosion, and carefully examine the bearing seat area for cracks and corrosion. So ABC or 1, 2, 3, these areas, if you break them down, lug area, and then focusing on the bulletin, it specifically calls out crack in the lug area. And it's showing you a crack here, simulated crack. And I tried highlighting again over here on the lug areas. You're going to have 4 of those. That's where your attach bolts go through the pedal mount bulkhead. And the lug areas, go ahead and inspect all the way around them. But the most common we found was right where they come down into the bracket assembly or go up in this area. So that's the lug area, focused in on that particular area and all around. And just a side note, you guys want to check on the top of these areas as well, the attach points on the aircraft's heel strips, to make sure they're not bent and chafing down in this lug area, okay? Because that's going to weaken that material. It makes it a lot thinner and it could crack out. So that's the lug area identification. Next, if you look, it has the web area. Okay, and then you come over here to example cracked and it says web area. This is down in the bracketed area, kind of more in the webbing, obviously, versus down in the bolt lug area. And again, it's in this general area, but it starts going up into the webs. Okay, so that's the web area. Carefully examine the bearing seat area for cracks. And the bearing seat area is going to be at the bottom here, cracks in the bearing seat area. And there'll be a bearing inside here for your tail rotor pedal interconnects. And this was going to be problematic if you had bearings that are rough or corrosion is getting in here and it's causing the outer race to wear. And that's going to cause, again, additional stress in these areas coming out aft, cracked areas, or forward in the bracket area. So those are the 3 focused areas. Again, corrosion, don't be afraid to go down through these tubes, looking inside everything, behind them, checking the supports, the main supports here. So do 100% on everything. This is just a focused area on these 3 common areas for cracks. So if the magnesium bracket is cracked or corroded, replace bracket with applicable aluminum. So that's your forced upgrade and solution for that. There's no partial cracks or measurements you have to do. So any cracks identified is immediate replacement. If the magnesium bracket is not cracked or corroded, refinish any exposed areas. So again, over time, this bracket area, if you're looking at it carefully, you can see bubbling of the paint. Maybe some of the paint has been removed. That paint with the primer has a couple skins to protect that magnesium. If these skins or paint are not covering the magnesium, that's a big problem with corrosion and causing the weakening of the material. And being that it's located in the chin bubble with humidity, salt water, these type of areas. So if you have a good set, keep them clean, keep them inspected, make sure the paint is covered on there to prevent any of this from happening. All right, and this is a couple pictures here showing you the cracks and examples of the cracks. So on the left here, you can see the top one. This is in the lug area. We had a fracture across this area and a fracture across this area. The one on the right had a complete fracture, which could happen as you have a couple of these break and the pilots are pressing on them, they can break down there. This was done, a couple of these have been done just like we said, is the pilots are on the aircraft or crew members up there, and they're repositioning themselves on the seats and they're putting both legs full press on these things. And that's a lot of the reasons we're having these breakouts. They're not super common. They're pretty rare. I've been teaching for like over 20 years. And occasionally we hear these related on the ground. It's very rare that they've been reported in flight. And usually that was already a pre-existing crack. Again, the flight loads are not near enough to break this material. So it's just something to be aware of, focused in inspection ahead of time, making sure all those are prematurely inspected where you'd have no fractures. And the system's been around. These brackets are really strong, long time. This is another photo I wanted to add in here so you guys just see examples of the lug area. Okay, the lobes up here on the table, you can see, and then the fractures, so you can see where to look at exactly in the most highly potential area that's going to be induced on the cracks. And then a picture on the right showing you those inspect points, probably the most common one, if there's such a thing, but as reported, that's there. And then make sure you're inspecting the rest of the areas as highlighted earlier though. Okay, that was the first part. And then Bravo, continuing on the bulletin here, we have tail rotor pedal support bracket, non-destructive inspection. So your NDI, identify and install left hand, right hand tail rotor pedal support bracket. Part number, which we went through earlier, same, but this is the NDI inspection with the 300-hour or initial 50. Use one of the following NDI inspections. So you don't have to do them all, obviously, just pick one of them. The tail rotor support bracket for cracks. So on a 300-hour or your initial 50, you need to be focusing on how I'm going to do this. Am I going to do a fluorescent penetrant inspection? Okay, or am I going to choose to do the eddy current inspection? Or am I going to choose to do the dye penetrant inspection? And that's just like on any bulletin, you'll see a black bar on the side, and that's the additional we added. These will be referenced in a standard practice section in the HMI 2 and chapter 20-90. And within these first two, fluorescent penetrant or eddy current inspection, we're going to reference some engineering specs and aviation industry standards, which you must meet to do those inspections. And the dye penetrant inspection is more for the average mechanic to pull off and do, but this is going to take you a little bit more time to do, but this is more friendly for the mechanics. If you have somebody that's certified or yourself is certified, we're finding and hearing the eddy current inspection. Some people are rapidly doing the inspection quicker with the probes and getting in there and doing their measurements and signing these off as a quicker turnaround time. So call around for eddy current inspections if you have minimal downtime you can do. The fluorescent penetrant or dye penetrant, as you guys know, just give you some pictures of them. It's going to take a little bit longer to get in there, and paint removal and inspections for cracks, dye penetrant, cure times, developer, and that kind of stuff. So that's your big one. That'll ensure, for the most part, you're not having any crack seen anywhere. All right, so if, again, this is a 300-hour, it has the same rules. If you have magnesium bracket is cracked or you identify corrosion, replace the bracket with the aluminum one. So that's pretty, if none, repaint, primer. There's actually multiple steps here. As you guys primer and paint these things, you also want to treat the magnesium with a Dow 19. The aluminum ones, it would be obviously Aladyne, but you're not doing that inspection. But Dow 19 for the magnesium, then a top primer, and then the black paint is the top. So there's actually 3 layers. Pretty standard. Put the Dow 19 on for a couple minutes on the magnesium, let it sit, and then rinse it with water to neutralize it out. So you're going to be rinsing a lot of water, possibly stripper. So a lot of access to these with removing and dye penetrant inspections. So that's why I was saying the labor may be longer to do that. You may even have to remove them, protect your canopy glass. So a lot lengthier process involved there. Okay, so that's the service bulletin in a nutshell. Phase 2 of this is going to be HMI 2, temporary revisions, 1 and 2. So we'll go into that now. And these temporary revisions will be called out and in yellow pages. And this one, it's white, but it'll normally be printed out in yellow, and you slide these in. There'll be like 5 to maybe 10 pages total on a temp rev, different than our normal revisions. So temp revs are issued out as fast as we can. They're similar to bulletins, and we're trying to integrate time life changes or inspections that came off bulletins. So your maintenance manual is up to date, integrated with the latest critical items that we found in the field. So this TR1, you need to review this one in detail because it's the biggest one. It's going to add additional inspections from that bulletin and new 100-hour, 300 hours. And then there's the TR, the 2 one that came out, and it's just a refinement of this one. So, but make sure you read this one carefully. You can see a lot of pages in this one. Again, as these are issued, before I post them in the manual, or if you're looking at them digitally, pay attention to the bars on the side, because that's the integrated inserted information that's changed. Okay, so you need to quickly, if you're doing it, just go through and identify that's been updated, that's been updated. So that'll help you. This will be one particular page I pulled out in chapter 5 and component recommended replacement schedules from the factory. You're probably familiar with all these up here. This is the new one on the bottom. And we initially put out on temp rev 1 the 5,000 hours. So we were going to roll back and create a life limit on this bracket due to the couple cracking that we had. This will later be changed to back to on condition on the inspections based on the condition of those inspections. But I wanted to highlight this kind of created a panic in a way, but we took that back out. So that's 5,000 hours. This is the temp rev 1, another insert here, the black bar, chapter 5 again, and this would be your 100-hour inspections. It's pretty critical on temp revs and revisions to note the black bars and to see your 100-hour changes. And are we picking these up? Are we doing those new inspections to make sure you're doing them? Or the annual inspection based on calendar time there. So note it is permitted to use a bore scope to examine the tail rotor pedals support bracket. This is applicable on all our models. Examine the left and right hand tail rotor pedal support bracket with the 10 by magnifying glass. Mirror, bright light for cracks and corrosion. So reference within the inspection checklist, it's very important to pay attention to this. If they call out a reference to an inspection, tail rotor pedal support bracket inspection. And then next you come over here to the chapter and the section. This will be 67, 20, 10. So you need to turn to the ATA section and then focus in on just that specific inspection that's called out, not the whole inspection area within the chapter, just that one that's called out. Some guys will actually do the full inspections on these things, and we just want you to do that one. So down on the bottom of the pages too, they'll be listed here of the 1 and the reissue. So you can track that as well. Okay, the next screenshot I took out for you was the next inspection, 300-hour inspection. And this one is a black bar, all models, do the tail rotor pedal and assembly inspection, reference the same section. When you go in there, and we'll look at it here carefully in a minute, but it's going to list 100 hour, 300 hours. So you need to link those together. All right, and focusing in now on temp rev 23-2. And you can see this one had to do with the same stuff, but we were just tweaking it and modifying small minor things on there. So to go through that, again, back to chapter 5, and we have this noted on the bottom. It just deleted all that. So we're back to the normal list we're used to seeing. The pedal brackets are no longer on there. So now we're putting it on that inspection interval. So it'll be on you guys. So those who don't have a problem, keep operating, keep using the magnesium. That, like I said, they've been around a long time and they should be good. So just watch the corrosion. All right, and we have temporary Rev 1 and 2 listed here, inspections added, and some maintenance finding picks we're going to go through at the end. So let's go through the chapter 67. And if you go to the maintenance manual, I actually added this 100-hour in there. It's something that we probably need to add, but it will reference anyway in there. Tail rotor pedal support bracket inspection, 100-hour. This is the first one at the beginning that will be called out, figure 602. There's a figure with it. It's similar to this one in from the bulletin as well. Consumable materials will always be listed at the top. And the chromic acid, which will be CM207, go to chapter 91 at the back of the maintenance manual and look up CM207. It'll probably be listed, as I referenced earlier, a Dow 19 to treat the magnesium, and then epoxy primer, okay, basic primer on there to cover it. So note, it is permitted to use a borescope to examine the tail rotor pedal support bracket. And again, this is pretty user friendly when plotting ahead. It's nice to have one of these because this is a tight area, especially those with the round nose. The pointed nose gives you a little bit more room. You might also want to put a blanket or something down in the canopy glass, just if you drop something for damaging it. Try not to lean on the glass too much though, because you could cause some damages with your body weight. Okay, going back through here, number 1, examine the left and right hand tail rotor pedal support bracket for cracks and corrosion using the 10 by glass, mirror, or bright light. Carefully examine the lug areas for cracks and corrosion, and we identify those areas. Carefully examine the web area. Again, we've identified the web for cracks and corrosion, and carefully examine the bearing seat area at the tubed ends on the bracket, on both ends of the bracket, the bearings. So if there's a crack or corrosion, replace the bracket. So this is word for word, pretty much right out of the bulletin, dumping into the maintenance manual as a new norm. If there are no cracks or corrosion, refinish exposed with the chromic acid. Up there they go, Dow 19 is listed here, or equivalent. If you guys use something else, there's a couple equivalents. This is a commercial name, so we'll list equivalents, or you guys can find equivalents off the mill specs. Primer, CM325. That's a base, usually 2-part mix or primer coat, and top coat paint. Okay, so there's your skins or coverage back on the magnesium, keep you from cracking or causing the corrosion. So that's the 100-hour inspection or annual, and it's the visual inspection. Okay. Next, we have the tail rotor pedal assembly. This will be in the maintenance book in the same section, and it'll say examine the components at the left and right position. On the right-hand command models, make sure that the related pedal contacts stop simultaneously. So they do have a problem too. We have some reported problems. It mostly has to do with tail rotor rigging, or if mechanics have been in there doing your 300-hour, you're going to be doing the tail rotor rigging. If you loosen up any of these bolts, okay, and you start repositioning this stuff and retorque it, you have an alignment that you need to maintain with this interconnect tube, and you have a tail rotor rigging. If you disconnect or reconnect any of the linkage in the tail rotor assembly, you need to verify the tail rotor rig. It should be minor, but you may have to adjust. I would focus in on the mid pedal position and the tail rotor control rod that goes to the tail boom to make sure that is first checked. And then you do the full right and left pedals. Doesn't matter which one you do first, right or left pedals. And there's some stop bolts down here. And you want to make sure if your left-hand command that those bolts are hitting the stop bolts. And then there's a gap check on the associated other side, which would be the co-pilot side of 1 to 3 thousandths gap check. So they'll be just off those stop bolts. And the closer, like a piece of paper, you should be able to slide in there. But that causes twisting and preload and stress on these brackets as well. So ensure the tail rotor rig is set properly, not just from the 300 hour, but it's something that could be checked and reassessed as you're doing your initial on these inspections too. If the tail rotor rig is out, the tail rotor stop bolts are not set right, or if somebody's adjusting the tail rotor rig during the tail rotor, if it's not done properly, you can also cause a lot of stress in this area, especially when shortening the bolts. So if you're doing any adjustment on the stop bolts and you're shortening them, you need to make sure you go to the associated other side and draw those bolts down. But either up or down, always remember they're always moving together, and you can twist these interconnects when doing the tail rotor rigging. So anyway, so go back to the 300 hour tail rotor pedal assembly inspection. So examine the pedals for cracks, elongated pedal attach holes, and open drain holes. So we're looking for all this stuff. Examine the Teflon reinforced bushing liners for deterioration. Examine the pedal to arm, quick release lock pins for condition and positive spring action. So these are all your associated detailed inspections now on the pedal assemblies with the little quick pins, checking the holes, make sure they're not elongated. So we're doing 100% on this pedal inspection. The 300 hour is our large inspection on the 500. So make sure you're doing a thorough inspection on this stuff. Examine the links and the bell crank for cracks and bends. These are a couple lollipop links you have down here on both sides. Your left pedal is bolted with an expandable bolt through that tube. Okay. And then when you push on that one, it pushes down through the lollipops, these links, and pushes back on the right pedal. So the right pedal is like floating on some bearings on that tube. So basically inspecting that bolt, make sure it's gapped out. The washer should not contact the pedal. It's expanding from the inside and it's pushing back and forth, inspecting all this stuff. Examine the bearings for too much play. Okay, these should be minimal play, couple thousandths. You got any radial play, that's bad news. Axial play in here, these bearings will be sealed up on the ends and they should last you a long time. So any kind of roughness to these bearings is not good. And pay particular attention to the outer race of the bearings. Okay, that's the outer race play within the housing and the casting. That would be problematic and create elongation and play in the system and also create cracks coming from the bracket. So that's not even corrosion related. That's just installation or extreme long-term wear. And that's a standard practice on all the bearings. So outer race is really not accepted anywhere. So examine the control rod fitting, torque tube, mount bracket, and pedal support brackets for cracks. Use your 10 by magnifying glass, mirror, and bright light. Lighting would be critical in this area. Carefully examine the pedal link, bell crank fitting, pedal bracket in the center forward area where control rod fork piece joins in the tubular section. So all this in the front area as well, supporting all this forward pedal bracket stress, inspect all that stuff. If there's a crack or corrosion, replace the bracket, which we went through. Do a check of the bracket for loose bearings and replace a bracket with loose bearings. So all this stuff, obviously replace any of it. Do the following steps for the tail rotor pedal support bracket. And this was the small highlighted area in red. I wanted to highlight this was the change. So we did the initial issue on the rev, and then we added on rev 2 the dye penetrant inspection. So that's another option. Instead of just eddy current and fluorescent penetrant inspection, we've added the dye penetrant inspection in there on 2. Okay, replace the bracket with cracks. Examine the torque tube for cracks, scratches, nicks, dents, and other similar defects. I had mentioned it earlier, but I'll mention again, the top area in the heel strips that are not shown in this picture, but they go right over the top here. Make sure your heel strips are straightened out. They're not bent and they're not down here chafing on the bracket assemblies. Okay. So. All right. In the last area, I just wanted to cover kind of to touch on, because it's related, is your tail rotor control area. If again, it's pretty likely if you find something, you're going to be disconnecting, removing, reinstalling, and 300 hours, you're already to the tail rotor rigging check. There is adjustments, full rigging, which is from nose to tail, but there is also just checking from the backside, which is most commonly done is the check. And then if you had areas of concern or problems doing the rigging from the backside on the tail rotor, you would move forward and possibly have to do a full rig out. But checking, it's most common. You guys are probably used to doing that. This is a picture on the left showing the pedals, inspection of any holes that have been blown out, or inspection of these pedals to make sure they're in good condition. There's also a square shim that can be installed in here and laid out to shore up any kind of rattling. Sometimes you'll have the pedals that have looseness at the top here, and you'll want to reduce that with any possible shims that are needed in there. There's actually a shim set. If you guys don't have them, you might want to look into the parts manual and get a shim set to make sure these are not super tight, but snug and not rattling the pedals and causing additional wear. Okay, just to reiterate some things on the tail rotor rigging that you guys should be aware of. Clamp the pedals. There's in the maintenance book, it shows you the old OH6 H model block and twine. That's all you have, but make sure you block those out. Most commonly, guys will block up by the pedals, but it's a little harder to grab. But make sure these pedals are not bent. So when you block them at the bottom or at the top, they need to be in line with each other with zero tolerance. If you block them at the bottom, then these could be slightly bent a little bit, and they're telling you like a 1/4 inch misalignment at the top. So it's really just to focus you in on clamping the pedals exactly to one another and the tolerance of the tube itself between the two. Okay. If it's beyond that, then that's a misaligned pedals. One's bent and you need to change it. But for clamping, always make it consistent on your helicopter. Always make it the same. And the base is really good to do, or at the top as well, so there's kind of a verification for bending, and then there's a 100% alignment for tail rotor. This needs to be 100% aligned. You're going to go back. This is with the tail rotor boot removed here or pulled back onto the fork is preferred. And there's a special tool here for the rigging tool, tail rotor swash plate rigging tool. It's plastic. You guys should have these. There's 2-bladed, 4-bladed, different versions. And the first one up here is mid position. It'll show you mid travel rigging. And that one needs to be checked in the mid position. And it goes all the way down on the spline. It should be perpendicular, 90 degrees, and off the split ring, and it should not touch the fork. So it should just be down on the shaft next to the split ring, not on top of the split ring. There's a small split ring in here. The left and right pedal positions are shown with the tool here. You just rotate it around or flip it upside down. So it's a 3-phase tool. Always check mid position. Okay, the pedal stops will be down below. And there's a photo of the pedal stops and the jam nut to loosen and adjust the height of this bolt and retorque your jam nut. This casting piece from the pedal will come down and strike that. Okay, normally these will not be painted. And if you have paint on them, it should be metal to metal. Paint's okay up on the top, but not on the bolt. All right, the mid position, I wanted to show you a photo of this perpendicular. Again, the split ring, not up on there or at a different angle, making sure that. Remember the mid position check first. In the control rod that comes out, you'll have to go up to the access maintenance panel, remove that, break the jam nut loose, and then turn the control rod. That sets the mid position with the pedals clamped. That one's the critical one to do first. I also highlighted in the next drawing here, circled in here, this is your control rod. This is your check adjustment. And this is the one where most of the mechanics will be adjusting this. Break the jam nut loose on the forward end, access the panel, and turn the control rod from the back to the nearest half turn to install the mid position special tool back on the fork assembly. You can see the back end will be riveted, and there's a jam nut there for safety backup, but all these rivets in there. But the front one is where we want to remove that, and then that allows you to rotate the complete tail rotor control rod. You'll have to remove that on the 300 hour, but that will be your adjustments for mid position. If something was adjusted up on the pedals, or the bolts were set different, or the pedals are sitting a little different, and you retorqued them down on the bulkhead, that could cause a little adjustment on this tail rotor control rod. Once the mid is adjusted and checked with the tool, you need to check the right and the left pedal assembly on the stops as well. So make sure you guys are doing a tail rotor rig check. There's another picture of a left pedal rig position. You can see this is your maximum pitch. And what do we have here? So the tool's installed and it's up on the split ring and it's not perpendicular. It's kind of off to the right a little bit. So this pedal stop bolt will need to be adjusted. Okay, so we can fit it down flush on the shaft and perpendicular. So make sure you're doing that. The bearing play will come out if these bearings are played or worn. This is when you push the tool down, you're going to see the swash plate move in. That's really the cumulative play of the pivot pin, bearing, rod end. So you might want to isolate where you have that play out. Minimal movement here, like 5-10 thousandths, something like that could be in there. That's normal. But if you're seeing it move a lot, you need to investigate that for play. Also in this pitch control could be worn and the shaft could be worn. So the pedals are set from the front. If you have an assistant, that would be helpful to hold the pedals down. And then another mechanic is in the back inserting the tool. It should just slide in on the sides and then look for this to move, again, to identify a secondary problem within the bearing. But it should just be snug. The tool should hold itself on there and you should be able to let go of it. It's somewhat snug in there. It's a nice fit. Going back to the mid position, this will be to the nearest half turn in its precision and fit. This will be precise to the pedal stop adjustments for left and for right fitting. Okay. Last thing to cover in this brief would be associated areas of inspection. After you cover the bracket, don't overlook the interconnect torque tube that has its own inspection. It's a 500 and it has 5 bolts, adjustable bush. Okay, bushing assembly right here, expandable bolts with the bolt. So we have one on the left pedal, one on the interconnect here, and then another one on the interconnect, one underneath your console. Okay, and then one on the left pedal over on the pilot side, or if you're aircraft, that'd be co-pilot. So we have 1, 2, 3, 4, 5. So we have 5 expandable bolts to make sure those washers are not contacting the tube. They're spaced off of the tube. That ensures a proper expansion torque value on those bolts. If any of those are not installed correctly, it could cause elongation and cracking of that tube. It also creates preload within the pedal assemblies. So these are shimmed out as well behind the bracket assembly. So if you guys are removing these brackets for the NDI or any other inspection, make sure you pay particular attention to any washers that will be underneath the bulkhead in the bracket assembly inside there. Okay, those are angular in alignment for the bracket. So the interconnect fitting here will slide back and forth. Before these are connected, make sure this sleeve jumps from left to right and it's smooth out. If you need to, you can add washers underneath this bracket to change the alignment of this tube to this tube so it slides back and forth real easy. And that'll be a sign for inspections too. As you're inspecting those 5 bolts, if you get one that's loosening up, you may need to shim your brackets properly. They may not be shimmed properly, which is creating a preload condition. So, all right, and another picture of a right pedal rig. It's right's tight on this area. So, okay, and that's the tail rotor pedal assembly. Additional visual inspections covering this. I wanted to show you some photos. Another bulletin that you guys should be familiar with, and that interconnect cracking on the bottom left here, emanating from at the bottom inside. So your Hobbs meter will be located down below here at the foot area, either on the left side or the right side. You need to remove the access panels here with the screws. Make sure you have a nice cross tip bit to get in here and a ratchet. Take this panel off, make sure it's not chafing on the tube as well. That'll give you access to do this inspection as well. There's a ABC bolt installed there, which could be installed either direction. This is installed with the nut facing forward. But remember to remove those panels underneath your console and inspect those areas, not just the visual ones to the canopy glass, but you have to remove the access panel underneath the console to get that last 5th bolt inspected. Okay. Again, so we could see a left pedal bolt here inspected, the 2 interconnect bolts with gaps, torque stripe, see if they're rotating, the one underneath the console, and then there's one more way over on the left. You can see one of the stop bolts here with the jam nuts, the CAD plating on it. There's another example of your tail rotor control rod going underneath, and then the ABC bolts and gaps, always gaps in here. Okay, so you can do a quick visual back through these bolts, tell you that's good installations on there. Any kind of washer up beneath the side is going to create elongation, improper torque values. And the last couple pictures we have here are examples of small spiral cracks coming out, emanating from those areas. Again, improperly installed, over torqued, under torqued ABC bolts. This stuff I've seen installed, it lasts years with no problems. Improperly torqued, it could create cracks. So make sure you guys are torquing those fasteners upright. Again, spiral cracks, more examples of this. These are not super common, but they could get you if they're not installed correctly. And one last picture there, showing you an example of another crack. All these from inside bore scope, outside, they could be seen pretty easy. All right, the last things are pedal loads as well. Just to be aware, in the HMI 2, there's a spring in the tail rotor pedal assemblies, and this just gives you a left pedal assist. It can be adjusted from the mechanic's point of view, and it sets the tension for cruise flight. Okay, so your pilot's pedal shouldn't be climbing left or right based on your aircraft built out of the factory. They're normally set, but I just wanted you guys to be aware you can adjust these from inside the seat box to outside the seat box. It's not commonly done, but it sets the pedals for cruise flight. It's within the tail rotor assembly. There's a picture of it. And again, be aware this is in the system, so you may need to remove it. And there's a tail rotor special tool to grab and stretch the spring assembly. Some customers also use popsicle sticks or tongue depressors, and they stretch the spring and then put the wood in there and then just unhook it. But this is going to preload a lot of your tail rotor assembly in the flight control. So as you're removing bolts or installing bolts, if you're feeling tension, you might want to pull the spring out to remove that tension, and then everything will free up. So the tail rotor assembly is on a spring tension. And this is a last item, just some areas to inspect for. This is the pitch control with the swash plate, the pivot pins, and the bearings inside there. Make sure as you need to shim out things for clearance on the tail rotor control rod and checking all this stuff for play. play on the tail rotor assembly will always emanate from the most highest vibration, the tail rotor link, and then it will creep back. These are your most highly worn areas. Okay, I hope that helped you guys. And again, as a tech brief on the tail rotor bracket assemblies. And I guess I'll leave it open for questions or go from there.